Okay, in this final video, we are going to look at some application problems that involve bearings. And so this is kind of a way of measuring direction, and it sometimes is used with tracking with airplanes or ships on the ocean or other situations as well. So let's say a plane takes off with a bearing of, I don't know, we'll say 210 degrees. So what does this mean? Okay, so let's say that the plane is right here. Okay, and so this is kind of the starting place. What I'm going to do is I'm going to draw like a little compass here at that point, and then we're going to label north. And so the bearing, when it says a bearing of 210 degrees, it always is measured from north on around the circle. Okay, so 0 to 360. So 210 is like 30 degrees beyond 180. So it'd be like kind of like maybe this. So this angle here is 210 degrees. So what it means is that the plane takes off in this direction. Okay, and so that's what a bearing of 210 degrees would be. So that's the idea. It'll always be measured from north clockwise around the circle. So that's very different than when we use the unit circle, because we measured from the horizontal, the positive x-axis, and we went counterclockwise. Here we're measuring from north and we're going clockwise. Okay, so let's look at a problem here. So it says an airplane takes off with a bearing of 85 degrees. Because of bad weather, it turns back around with a bearing of 283 degrees and lands at an airport of 230, or at an airport that's 230 miles directly north of where it took off. What is the total distance the plane traveled? Now I'll tell you, these bearings, if you don't normally use them, they're very unintuitive, and you really gotta think about these. Okay, and I'm not the best with these myself, and so I'm going to kind of start in the middle, because I'm not going to know exactly how things are going to go around, but I do know it's going to end north of where it started. So I'll start kind of in the middle, kind of more near the bottom, and so we'll say this is where the plane starts, and I'm going to draw like my little compass. There's north, right? And it says it takes off with a bearing of 85 degrees. Okay, well, 85 degrees, this would be 90, so directly east, that would be like 90 degrees. So this is a little less than that. It's like this is a 5-degree angle there, right? So this is actually the bearing here of 85 degrees. And what is going to happen is, due to bad weather, it actually turns back around. So it's going to be turning back around and landing north, directly north of where it starts. And it says it gives me a distance, 230 miles directly north of where it starts. So let's say it keeps going, and at some point it turns around, and then it actually is headed with a bearing of 283 degrees. So let's see what's going on with that. So there's my compass here. Oops. And 283 degrees, well, this is like 270 degrees, right, if you go through 3 quadrants. And then I'm going to be going like 13 degrees more, so kind of like this, I guess, until I land directly north. Okay, directly north. So this angle here would be like 283 degrees. Okay, and now what it wants to know is what's the total distance that my plane traveled. So it went it went 230 miles. No, oh, sorry, this distance here is 230 miles. So this distance is 230 miles. I don't know how far it went before it turned around and went back, but I do know the bearing, and it turned around and went back there. Okay, so it looks like I'm going to have an angle and just one side. So two angles and a side. That's good. That's what I want for like a law of sines problem. Now the question is, which of these angles can I actually figure out, and how do I do it? Okay, so what you're actually going to use with a lot of these is this idea of if you have two parallel lines and this is a transversal that cuts it, then like these angles are equal, or this angle and this angle are equal, those alternate interior angles, or this angle and this angle are equal. There's all kinds of equal angles. Okay, and what the parallel lines are going to be here they are going to be the compass, right? These compasses, points that run north and south. Okay, so one thing here is that this line and this line, those are parallel. So this line here is like a transversal. Okay, and so notice you have like this here, so this angle and this angle are equal. And notice you know this angle, that's 5 degrees. That's 5 degrees. So this one is 5 degrees. Okay, so you know that that's 5 degrees. And then you also know that this is 283 degrees. And if you go through 3 quadrants and stop, that's 270 degrees. So maybe I can zoom in on here. Maybe that would be helpful. Right, so that's 5 degrees. And so this is 270 degrees. So this angle here is actually 13 degrees. So you got like a 5 degree and a 13 degree. 13 because you have 270, or you have 283 minus 270, leaving you with 13 degrees. So what you really have is a triangle kind of like this, right? Where this angle is 18 degrees because I'm adding the 5 degrees and the 13 degrees. And this one is 85 degrees. That one was easy. And I know this side is 230 miles. Okay, oops, and I'm sorry, let me zoom back out. So it's like you have this kind of triangle. So I have to figure out these angles, and that's not easy to do. You gotta kind of think about these transversals and find that. You'll have to really think about that. It's not the easiest thing in the world, but that's what I would have here. And so now I can call this X and this Y. So I traveled from here to here, turned around and went back there. I want to know how far I traveled, so I want to know X and Y. Okay, and now I'll need to know this angle here. So basically 180 minus 85 minus 18, that angle here is 77 degrees. So for the X, it's basically X is to the sine of 85 degrees, as 230 is to the sine of 18 degrees. Okay, so basically X is equal to 230 sine of 18 degrees times the sine of 85 degrees. And that's going to give me my X here. So 230, maybe I can zoom in on that a little bit. So 230 divided by the sine of 18 times the sine of 85. And this is, it looks like X here is 741, and let's just round to the nearest mile. So 741 miles. Okay, now I can find Y here. So basically I have Y is to sine of 77 degrees as I could use this one again. 230 is to the sine of 18 degrees. Okay, so basically y is 230 to the sine of 18 degrees times the sine of 77 degrees. So 230 divided by the sine of 18 times the sine of 77. And this is equal to 725. And that, I'm just going to do it to the nearest, this would be miles, to the nearest mile. So we basically have here 741 plus 725. So 741 plus 725, and that is equal to 1,466 miles. So that's how far the plane traveled, okay, in its journey there. So that's the idea behind the bearings here. I have another one. So let's try one more to just get some practice here. So basically, a boat takes off the west coast with a bearing of 255 degrees, travels for 45 miles. It changes its bearings so that, it changes its bearings at that point to 310 degrees so that it can land on an island for supplies. How far is the island from the boat's starting point if it would have to take off from the island with a bearing of 100 degrees to get to that starting point? Okay, so let's think about this. So west coast. So I think we're taking off on the west coast going this way, I think. So I don't know. We'll say that's the west coast. And we're going to take off here at this point. So let's make our little compass here. So it takes off with a bearing of 255 degrees. So if I go all the way around and go directly west, that would be 270. So it's not quite directly west, right? It's going to be this way. So this here is 255 degrees. Okay, and also I know, and this will probably be helpful, is that this would be 15 degrees here. That might come in handy because all the way to the horizontal there would be 270, right? And it travels, it says, for 45 miles. So we'll say that's 45 miles at that bearing. And then it makes a turn at this point here to in the direction of a bearing of 310 degrees. So let's draw another little compass, and 310 degrees. So this would be like 270. So 310 would be like 40 degrees. This here would be like 40 degrees, right? So so basically from here to here is 310 degrees, and this would be like 40 degrees. That would be 50 degrees. Okay, so that you can start seeing how we might do this sort of thing, how we might start getting these angles. Okay, now it keeps going. We don't know how far, okay, but where it stops is where this point, to go from here to there, would have a bearing of 100. Okay, so it's going to have to be quite a ways, because if I went directly east, right, if I went directly east, that would be 90. Okay, so I actually want to go even further than I would need for directly east so that the bearing will be 100. Like, I don't know, like something like that. So, but I want this to be such that if I went here to there, that this angle would be 100 degrees. And not only that, but that would make this 10 degrees, wouldn't it? 10 degrees. Okay. And so you got a whole bunch of information here. But we certainly can't assume that this angle is 15 degrees, right? But this and this, these two are horizontal, both horizontal, so those are like parallel. And so this 10 degrees and this 10 degrees, those are the same. Those are alternate interior angles. So I see that this angle of this triangle, and I could maybe draw this triangle again if I wanted to. This angle is like 25 degrees. So I found one angle. This is 45 miles. Okay, can I find another angle? So all I need is like one more angle, right? Well, I think I can, because I think this one here, if this is 40 degrees, how do I know that? Because this is 310, but to go to this point up here is 270, so I'd have to go 40 more degrees. That would make this 50 degrees, right? So let's see if I can do, this is 15, so this would need to be 15. Here, this and this is horizontal, so 15 and 15. So that would make this 65 degrees, I think. And so if I could zoom in on that, maybe. So 65 and 50 there, that would be 115 degrees, I think. And so this would be 115 degrees. And I think that's all I need to know, because what it wants to know is how far is the island from the boat's starting point. So it wants to know this, it wants to know that distance right there. Oops. So if this is my triangle, it wants to know this. So that's 25, that's 115. Again, you have to figure out those bearings. It's not the easiest thing to do. But now that I have them, it should be pretty easy. So I got x is to the sine of 115 degrees as, oh, I need this angle, don't I? So 180 minus 115 minus 25, and it looks like this one's 40. So as 45 is to the sine of 40. Okay, so x is equal to 45, or the sine of 40, times the sine of 115 degrees. .45 divided by the sine of 40 times the sine of 115, and this is 63 miles is what this would be. So this would need to be 63 miles, okay? And that seems like that would be a lot longer than 63, but my angles are probably not all correct. Okay, so that's what I get for that. So that is problems involving the bearings. You got a couple of those on the homework as well. So hopefully that gives you what you need to know. If you have questions on this homework assignment, just shoot me an email and I'll do my best to answer them. So have fun with that, and look for stuff with the law of cosines coming up. That'll be a little bit later this week.